A very good morning, everyone. A very warm welcome to all the speakers, panelists, and our sponsors, Hitachi High-Tech Analytical Science, and their participants. It is indeed an honor to represent Material Recycling Association of India, and I welcome you all at this MRAI's webinar on cost effectiveness and role of advanced technologies in the steel scrap recycling business. Just to give you a glimpse, MRAI is the National Apex Association of India, representing the interest of recycling industry with over 1,200 members, including most of regional trade and product associations. Our collective strength is over 20,000 small, medium, and large enterprises, directly and indirectly employing more than 25 lakh people. So during this pandemic times, the biggest challenge what the industry has faced, and I'll say mostly about secondary steel sector, their overall cost has increased, whether it is in the form of raw material cost, whether it is in form of electricity cost, transportation cost, logistic cost, or labor cost. Everything has increased. So our main focus in today's webinar is how we can, with the help of advanced technologies, how we can help our industries to minimize or get our cost effective in this COVID times. So in our webinar today, we have following esteemed speakers: Commodore Sujit Samadar, he is a former senior consultant at Niti Aayog; Mr. Frank Thews, he is a general manager for Global Distribution OES Germany; and Mr. Adrian Smith, he is the Global Sales and Service Director for Hitachi High-Tech Singapore. With this, I would like my colleague Sufyan to play MRAI introduction video. Sufyan, please play the video.
MRAI is the Apex Association of India, representing the voice of the Indian recycling industry, with a vision to promote responsible recycling in the country. MRAI was established in the year 2011 as Metal Recycling Association of India, with a focus on secondary ferrous and non-ferrous metals. However, over the years, MRAI has expanded its reach to include other recyclables such as plastic, paper, e-waste, tire and rubber, glass, automobiles, etc. The name of the association has since been changed to reflect the same, and today Material Recycling Association of India has a collective strength of more than 1,200 members, representing various recyclable commodities and comprising over 20,000 small, medium and large enterprises, directly and indirectly employing 25 lakh people. Recycling has multifold benefits beyond just saving landfill acreage. To list a few, it replaces the need and dependence on finite virgin materials such as iron ore and bauxite, and increases the resource security of the nation. Use of recycling processes consumes less energy and water and reduces greenhouse gas emissions when compared to primary processes that use virgin ores. Recycling generates 6 times as many jobs as just waste management practices. Recycling is a pan-India activity employing people from all backgrounds, including women and low-skilled labor. Recycling industry requires less capital investment, has a lower gestation period, and can be set up close to generation and consumption points. MRAI is officially recognized by the Government of India, and it regularly interacts with various departments at a local, state and national level. MRAI has worked with many government ministries on different policies and studies related to recycling, such as the Draft National Material Recycling Policy, Niti Aayog, Steel Scrap Policy, Ministry of Steel. End-of-Life Vehicle Recycling Policy, Ministry of Road Transport and Highway. Resource Efficiency Policy, MOEF. Study on Ferrous Market in India, JPC. Study on Aluminium Market in India, Ministry of Mines, and many more. Our industry contributed to the government's Swachh Bharat, Make in India campaigns and policy of Plastic Park. India's recycling rate at a meager 20% is well below global averages. We all need to collectively work hard to promote recycling as a sustainable business model. MRAI's vision is to work alongside industry and government and help create advanced infrastructure and right policies which could push the recycling rate above 50% in next 5 years. The world is working towards zero waste policies and circular economy concepts. India cannot afford to be left behind. The trade and free flow of recyclables must also be promoted so that Indian consumers and manufacturers continue to have access to environmental friendly and competitive resources and raw materials. We strongly believe that scrap is a mine above earth, and any wastage of scrap or impediments in recycling is a crime against future generations. From this platform, we would like to thank all our members for their long-term association with MRAI. We invite all of you to continue on this journey with us as we work towards making India a global recycling and manufacturing hub with sustainable growth. MRAI, Material Recycling Association of India, the voice of the Indian.
I would like to thank our sponsors, Hitachi High-Tech Analytical Scientific Solutions, for sponsoring this webinar. By not taking much of your time, I'll now request my colleague, Mr. Pramod Sinde, who is the head of communications at MRAI, to take this webinar ahead. Pramodji, over to you.
Yeah, thank you, Amaji. I'm audible now? Hello? Hello?
You're audible, but your webcam is, we can't see you. Yeah, go ahead.
Yeah. We once again welcome distinguished speakers and delegates to attend for the MRS today's webinar, which is cost effectiveness and role of advanced technologies in the Indian steel scrap recycling business. The objective of the webinar is to discuss the important role of scientific processing and recycling of ferrous scrap, which is being generated for various sources and variety of products. In today's presentations of the distinguished speakers, will be covering the introduction of Indian ferrous scraps industry scenario, then disruptive technologies for the green recycling. Then we have that distinguished speakers from the Hitachi to discuss more on cost effectiveness and role of advanced technology. On-site and laboratory QAQC requirement for scrap processing centers in ferrous scraps and carbon steel scrap materials. Among all the distinguished speakers, now I would like to call upon Commodore Sujit Samadar, who is an ex-senior consultant at Niti Oil, who is going to present on disruptive technology for the green recycling. Mr. Sujit Samadar, Mr. Sujit Samadar, Commodore Sujit Samadar is he has graduated from the IIT Roorkee. Yeah. And and started his career as an engineer trainee with Tata Consulting Engineers Mumbai. And he was responsible for designing of air conditioning system for Narora and Koba power plant. Then after that, subsequently, he was commissioned into the Indian Navy in 1980. Samadar held various staff for warship command appointment and retired in 2009 as a principal director of naval plans at naval headquarters, responsible for plans, acquisition, and budget. Post-voluntary retirement, he served as a vice president, Operation Nova Integrated System, Tata Enterprises, latter director and CEO of Shinmawa Industries India Private Limited, which is manufacturer of PF the FAM US 2 amphibian aircraft. Samadar was senior consultant industry at Niti Aayog, Government of India until January 2019, where he drafted India's first national maritime policy as well as the material recycling policy and prepared the concept note for the FDI in defense manufacture of small arms, production of civil aircraft in India. He is presently advisor aerospace and defense at FICCI committee as an advisor, and so he is an advisor at Material Recycling Association of India and distinguished fellow at Center for his Air Power Studies, New Delhi. He is founding member of Honorable Secretary of the Society for Aerospace, Maritime and Defense Studies, whose primary agenda is Atmanirbhar Rakshak Utpadan, and he also mentors includes various service chiefs, former ambassadors, industrialists, CMDs of ISRO and PSUs, and secretaries of Government of India. I think with this, I would like to welcome Commodore Sujit Samadar to present his today's presentation on disruptive technology for green recycling. Over to you, Commodore Sujit Samadar. Thank you very much. Sujit Samadar, sir. Over to you now. Please unmute yourself, sir. Sujit, sir, please unmute yourself.
Okay, can you see me and hear me?
Yeah,
Yes.
please go ahead.
Go ahead, sir. Go ahead,
Okay. First of all, thank you very much for the opportunity of being here today to speak on a very important subject, as we will discuss throughout this morning, on how the new technologies are going to impact the overall recycling business. Are you able to see my screen?
Yeah. Not yet, sir.
We can see the screen, but your presentation is not on.
So, where does that come?
So it's downside.
Right. Have you got it? Is it visible now?
Yes. Yes. Yeah. Sir. Go ahead.
Okay. So I'm going to be talking about disruptive technologies for green recycling. And since we've already taken a lot of time, I'm going to run this through as quickly as possible. But first of all, thanks to MRAI and all the participants today to join in this a very important session on discussing the future of Indian steel recycling industry. Admira DHES is a Canadian organization run by a friend of mine, which is a research-driven technology company. It deals with industrial gases. It does a lot of work on electric light railway projects in the United States, and it is one of the pioneers in developing green hydrogen technologies. For today's presentation, I'm going to be talking about the policy envelope in India, the implication and a use case, solutions, and some business partnering ideas. So let's look at what the policy envelope in India is. At the apex level of all recycling is the Environment Protection Act, which behoves upon the government for taking all such measures as is deemed necessary or expedient for the purpose of protecting and improving the quality of the environment and preventing, controlling, and abating environmental pollution. Then under the EPA Act, 1986, various rules have been framed under municipal waste rules, battery management rules, e-waste management rules, CND waste management rules, hazardous substance, plastic waste, aviasive rules, battery rules, tire rules. Lots of these rules have been framed for compliance by industry to make sure that the environment is protected and the business is sustainable. In the recent 2 years or 3 years, there's been a major thrust on recycling. In fact, the Prime Minister of India has been on record advocating 6 hours rather than 3 hours, as you have heard, probably in the Dubai um, intervention that he made. And he's been a champion on recycling in India, including the Swachh Bharat mission and many other initiatives that the government has taken in recent years. One of the key documents that has been produced is the National Resource Efficiency Policy, which puts down a lot of responsibilities on manufacturers and service providers. And line number 399 says use less and eventually no virgin material and more recycled or renewable materials in production processes. Then the Ministry of Steel has also come out with the steel scrap recycling policy in 2019, which says that scientific process and recycling of ferrous scrap materials generated from various sources and a variety of products need to be encouraged. Now, the steel scrapping policy of 2020 says that India will aim to develop a globally competitive steel industry by creating 300 billion tons per annum of steel production capacity by 2030, with a contribution of 35 to 40% from the EFIF route. Now, what does all this imply on ground? There are 3 implications. One is the requirement of scrap, the second is the requirement of oxygen, and third is the requirement of power. When you look at the requirement of scrap, using the metrics that are available for induction furnace and EAF and blast furnace and BOF furnaces for steel manufacturing, we see that we would probably need 100 billion metric tons of scrap by 2030 to just meet the target of 300 billion metric tons of steel that is required for our country to move forward. That's a huge jump, and this is at an extremely conservative basis. What is the present situation? We have about 25 to 27 million metric tons from Indian sources, and we are already importing 7 million metric tons per year. And if we continue on a business as usual forum, the best case scenario would be 50 million tons of deficiency by 2030. That's a lot of scrap that India would require to meet its steel production requirements. But where is the solution? The solution is quite evident in automotive recycling, whereas you know India is the largest manufacturer of 2-wheelers, 3-wheelers, and tractors, and the 4th largest automobile manufacturer. We produce about 30 million vehicles a year. We have already 230 million vehicles registered in this country, which is going to reach 800 million registered vehicles by 2030. Government has also come up with policies of retiring end-of-life vehicles after they reach a certain level of fitness or by age. And to just meet these requirements of vehicles in this country, we would need 100 billion metric tons of materials. And that includes aluminum, steel, plastic, copper, whatever else that goes into the steel, into the aluminum, into the automobile industry. So import dependencies are very high, and whatever we do, recycling is absolutely necessary for Atmanirbhar Bharat, as our Prime Minister has said so often in many of his discussions with the public in the recent 4 or 5 months. But looking at it, it's on a positive note, with 22 million vehicles which are going to be available by 2025, the material recovery is quite high. Ferrous materials, we can get about 62 lakh tons, aluminum 18 lakh tons, copper 3 lakh tons, plastics about 7.5 lakh tons, others about 10 lakh tons, amounting to little more than 1 crore tons of materials that can be recovered from these vehicles on the road. And the business opportunity of recycling and unlocking this latent value of material in our automobiles is worth 4,91,000 crores, or about $7 billion, which is lying trapped in our vehicles. So this is the scrap requirement. Now, if you want to look at it, what is required to make this scrap into steel? One of the ingredients is oxygen. Now, when you look at oxygen, to meet 300 billion metric tons and through the EFIF production route of 120 million metric tons, production per day works out to 400,000 metric tons. Then the oxygen requirement is 16 million meter cubes per day, or 22,900 metric tons per day. The present industrial capacity in our country is 5,000 metric ton per day. When you want to look at the power requirements for generating 300 million metric tons of steel, the numbers are also equally frightening. Today, we would require 80% of the total installed capacity would be required to meet the objective of 300 million metric tons of steel. These are not small numbers, they are very, very drastic numbers. So what is the inference? The inference is the recycling, the secondary sector cannot continue on a business as usual scenario. It is not sustainable. We need disruptive technologies, and those technologies are to be found in solutions where we have green oxygen, which comes from on-site systems, green power, which comes from on-site and hybrid systems, and green oxygen and green hydrogen, which comes through the hydrogen electrolysis process. With this, so how do we look at the solutions that come up? The first is VPSA technology. VPSA, as you know, is an absorption technology which uses the principle of pressure to separate the molecules of nitrogen and oxygen and argon, and through a filtration system to provide you compressed oxygen at various levels of purity as required by industry. It also has a very interesting PLC logic to determine the auto switching of generation of oxygen and purging of nitrogen and other impurities in the reactor vessel. So this is how it looks like. We can go into a lot of detail, but we are already behind it. But basically, it takes in air, it cleans it up, puts it through a silencer, puts it through a blower, and that goes into a VPCA bed, which is called zeolite crystals in it, and other sieves in it. And from that, it goes to the surge tank, which has got basically two tanks, a product chamber and a recovery chamber. And this is where the software controls it. So one of them is under pressure, the other is under vacuum. So when it is under pressure, it absorbs the nitrogen. When it is under vacuum, the nitrogen and other gases are released from the product chamber, and that switches, as I can tell you, it goes to a liquid oxygen tank and then coolers, and there's a metering system which tells you the purity of the oxygen that you want. And depending on the amount of purity oxygen that you want, this process can be improved in different ways. So this is one way of doing this, of making available the oxygen on site using atmospheric air. This is how it looks like. It's a very pretty compact system, and the system is some more details I'll show you as we go along. It has got plenty of applications in metal recycling, in oxy-fuel combustion, combustion of air enrichment, refining, smelting pulp and paper, water and wastewater treatment applications where oxygen is required. How does it look like? It's a very compact design. I'll give you some dimensions in a little while. It can be customizable because it only looks at these two storage tanks, and the number of sieves that we produce can also deliver the amount of oxygen that you want to generate. The operating conditions are specific to design and as per site, and it depends on the humidity in the air, the atmospheric conditions that is prevailing, the temperature, the dust quotient, all of that. So the operating conditions is a key requirement in the overall design of the system, and it can be fully packaged and they are on pre-tested kits. So that's very easy to install, and schedule erection is very easy. And this whole thing can be powered by renewable or hybrid energy, as we'll see later. Other features are, as I told you, the oxygen purity is controllable. You can go from 85% to 95% of purity. I think roughly about 93% is very good quality oxygen for the steel smelting business. Low power consumption, as you can see this number, it has only a 50% turnaround time, and it is the most efficient oxygen source in the world. Other features, it also allows for graceful degradation. That means it's never going to be a situation where you'll run out of oxygen because something is backed up. There are redundancies in the system, there are duplications in the system, and the whole system is designed in such a way that at all times you will be able to get the requirement of oxygen that you want, and it all works on a single button operation operated by a single operator. Of course, there's a lot of software which goes into it, so it's PLC controlled, and there are various dials by which you can check the purity, the flow, and it can also be enabled through Ethernet ports and Internet of Things to enable remote maintenance and remote monitoring of the plant. And there's no requirement for any sieve changes in a scheduled way. It is only in case of failure, which is far and infrequent. So this gives you on-site assured production and supply. It gives you the highest system reliability with minimal maintenance. It is independent of the market dynamics for supply of oxygen. It requires no input materials. It just uses atmospheric air. no transportation, no storage needed. That's a huge cost that comes down. No handling and shipping costs, lowest cost of oxygen, reduced emissions, and reduction in carbon consumption. There are some models you can see here that we can generate as little as 100 normal meter cubes per hour of oxygen on one end, with a small footprint of 2.5 into 9 meters, and we can go right up to a system that delivers 2,120 normal meter cubes per hour of oxygen in a footprint of 3.7 into 24.4 meters. So these are very good technologies, compact technologies that are available for completely revolutionizing the metal scrapping industry, the metal recycling industry, our smelting plants. But that is not enough. Whilst we're using atmospheric oxygen, we also need to take cognizance of the requirements of power. So how do you do that? And the reasons for going hybrid are well known, but where I would really like to touch upon is the novelty of this whole process, where we're looking at hydrogen generation and utilization as the value add to this whole project. So you have green oxygen and power, which comes through hybrid electrolysis systems. It generates on-site, online, on-demand green hydrogen and oxygen. Hydrogen is the future fuel, and we'll see, as we've seen in Delhi now, even CNG buses are enriched with hydrogen to get better efficiencies of the engines. So that is possible. It reduces the operating costs, reduces environmental pollution, displaces fossil fuels. There are no harmful emissions, and makes the recycling process green. Very quick understanding of how the hybrid energy system works. You can have solar, biomass, wind turbine, and microhydel. One of the advantage of using a composite system or a hybrid system of all these technologies is that you can generate four gases. You can generate hydrogen, you can generate oxygen, you can generate nitrogen, and you can generate carbon dioxide, which can be pressurized to create dry ice. Dry ice has got a range of applications in the food industry, in the entertainment business also, a large number of places. So a single plant which generates four different types of products in an energy efficient and green manner is the future. And all of this has got a main product, a byproduct, and co-product, as depending on the system configuration that you do. And for any user of such a plant, he has got clear revenue streams coming out of four products from one system, which makes sure that his costs are always balanced. Some very top level understanding of how the hydrogen system looks like. There's the electrolyzer, and on the other side there's compression, storage, and regeneration capacity. Today in the world, hydrogen is being stored at 900 bar, so which can also make a lot of difference. Particularly in India, one of the areas that we are looking at from Niti Aayog's perspective was the island developments, where we can use all of this in our islands to generate fossil fuel free power sources. There are also other applications that use both nitrogen and hydrogen to create ammonia, which goes into making nitrates, into fertilizers or various other industrial applications. So as I said, one plant, several product lines, lots of revenues coming in, and optimize your plant efficiency and profits finally. That's how the hydrogen electrolyzer layout looks like. That has been developed by our primary people in Canada. Not a very complex thing. It can be done. It's still a work in progress. The technology is to stabilize, and every day we are seeing improvements in the way we can draw out hydrogen through the electrolysis mechanism. The performance metrics are here starkly. Energy required 0.55, production is 0.6 normal meter cube of hydrogen. For that is roughly about 1.6 kilowatt hours per normal meter cube, and oxygen is 0.4 and 2.5 kilowatt hour per meter cube. These are very, very, very competitive numbers. So at the end of it, I want to just join here. The whole idea is Atmanirbhar Bharat, where we have a huge challenge ahead of us. 300 billion metric tons of steel have to be produced. We have seen the amount of work that we need to do in terms of the oxygen that we require, the scrap that we require, the power supply that we require. So business as usual not going to work. We need to disrupt this chain. And the earlier we do that, the better industries will become competitive, the faster they will grow, and we will stop ruining our environment any further. So the value proposition is we can do a direct sale from OEM to user, or we can do various sorts of business partnering options for Make in India. You can do a brought out design. We'll give you the engineering technical data package and the manufacturing technical data package. And as the system improves, those things can be further shared with you in terms of technology. Value addition in India would be greater than 70%, which is a very, very high number. And only the proprietary technology and the software may need to be controlled. Unfortunately, some of it is controlled by the US in terms of technology exports, but those permissions will have to be taken to be, and they are given, considering the close association between our two countries now, and a royalty and license fee production model is also possible. So with these words, I think I've already exceeded my time. Apologies for it, but I'm sure if there are any questions, I'll be happy to take them. And my coordinates are available with MRAI, and as a champion for the recycling industry, it's my truest desire to bring in green technologies in the recycling process. And some of the things that I've spoken to you about disruption in the recycling industry can be very useful for our friends in the recycling industry. Thank you very much, and thank you, MRI. Thank you, Hitachi, for the opportunity of speaking today. I wish you all the best, and thank you again for your patient hearing. Thank you.
Thank you, Mr. Samada, for such a valuable input on green technology. I have certain questions for you, but I think due to lack of time, we will take these questions at the later stage. Thank you so much. Now I would like to welcome our sponsors who will be giving the presentation going ahead. So Hitachi High-Tech Analytical Sciences have headquarters in Oxford in United Kingdoms. Hitachi High-Tech Analytical Science supplies analytical instruments, supports and service to a wide range of industry. The company is focused globally and specialized in quality control, compliances and safety certifications. So Mr. Frank Matthew will be giving a speech on behalf of Hitachi High-Tech. Just to give you an introduction about Mr. Frank. Mr. Frank Matthews is a General Manager for Global Distribution, OES, Hitachi High-Tech Analytical Sciences, based in Germany from last 30 years, having a global experience in optical emissions spectroscopy. Mr. Frank has extensively traveled in Asia Pacific, China and India, understanding market, customers need and future analytical requirements. He has also previously worked in the applications and method development teams and has acute knowledge of technology in the field of metal and non-metal industries. Mr. Frank, the stage is yours. Please go ahead.
Good morning, everybody. I hope I'm audible and
Yes.
You can see my screen already. Also from this stage, I would like to thank you very much to participate here. And during my speech, I will be switching off the camera just to save a little bit bandpass. So we are talking today a little bit about cost effectiveness and the role of advanced analytical technologies in the Indian steel and scrap business. And I have put a little bit an agenda together where we are talking about the Indian steel scrap recycling business towards the national steel policy, looking a little bit into the steel recycling methodology, the dismantling and the processing plants. And we are looking to latest technology in analytical instrumentation, how it can help in quality control, quality assurance. I'm giving a little bit of an example of the costs and suggestion for tailor-made solutions. Very essential is what we already heard from our earlier speaker, Mr. Samada, is software is very important. And also we have supporting software for the customer requirements because time and costs matter definitely. And When time permits, I will also provide you an additional suggestion, a challenge for the steel and scrap recyclers they might be interested in. While preparing this presentation, I have made references of various sources in order to put the evidences together, which makes this loop from the steel scrap industry to the analytical performance and quality control as an evidence. And the links will also show you additional information, which I cannot cover at this stage here. Before I'm entering and to start, I would like to give a couple of thoughts towards what we have already heard and where we are already in. We all know that our planet is crying out for help because as of today, we see climate changes, we see the greenhouse effect, we see various pollution effects which influences our daily life. But at this stage, at the same time, the world is demanding for growth. That is all what we are talking about and what we have seen. And as we are living in a globalized world, I think we have to definitely think globally, yeah, but all the findings to make the life, the planet, the world better, we have to implement individual steps locally. This is a part where we have to move. And one item which we definitely have to consider is that we, the people, makes the difference for a new normal life. If we consider all this, then we can cover the next subjects and the challenges the planet and the world is waiting for. We as Hitachi High-Tech Analytical Science, we are in this business for a very long time, and we are addressing this subject with additional 2 webinars I have already given on positive material identification for the Industry 4.0 in India, as well as the crude steel production and the scrap market in view of green environment. So if you are interested in this, we can set up at any time an additional webinar where I can guide you through this. The key point is here what we have learned, and especially if we talk about Industry 4.0, but also into the scrap business, it is government driven, and there is a loop. As government is supporting, we have the government, the industry, and the academia. These are 3 fundamental parts which have to work together to make the thoughts successful and the step we want to go. Looking to the Material Recycling Association's website, I found also parts for the non-ferrous scraps, understanding that we are talking about steel scraps here. But the highlight I would like to give, independent the type of scrap, we are looking to CO2 emissions when using scrap. And here you can see, using scrap, depending on the source and type of scrap, we can reduce a tremendous amount of of CO2. And this is not only relevant to the steel industry, also for the non-ferrous industry. And what we can see that the consumption of steels, especially also carbon steels, stainless steel, various steel scraps, has been increased over the years. And India, for 2019 to 2020, has imported so far 4.6 million tons of ferrous scraps. Of course, we have to understand the pandemic situation of COVID, which is a tragedy for everybody. And therefore, we have to see how to overcome, how to live with this and still meet the demand. And the demand for the market in the recycling industry, where the scrap is coming from, is home scrap. It is a prompt scrap and the obsolete scrap. And the obsolete scrap, that is an interesting part where we are talking about the ELV, the end of life scrap, which is coming from the cars, other vehicles, the ships, the bridges. And of course, we have to talk about aircrafts. And also what not has been so much considered so far is aging plants. In old plants, which are older than 100, 150 years, you have a lot of steels of scrap which is obsolete, which will be dismantled and can go back into the chain for scrap dealing and recycling. What is the government of India, the Ministry of Steel, how it is supporting? If we are looking into that part and why the discussion about scrap and recycling is coming up, in India, we have around plus minus a certain tolerance, 47 electric arc furnaces, but 1,128 induction furnaces. And this is where all the scrap is going. The scrap is the major source for these type of technologies. And the aim is where the steel production industry will have 300 million tons per annum steel by 2030, with having a contribution for the electric arc induction furnace routes of 35 to 40% of use of this technology. We have to consider it goes into the primary, but mainly in this purpose to the secondary steel industry. And this has an effect using scrap, minimization of the GHG, the greenhouse gas, the adaptation of the 6R rules to which I'm coming, and the Smart of India concept with where the government philosophy has already or is already undergoing various implementation processes. And the Smart India, the smart people, the Made in India is a concept which is supported and pushed by the government. And as long government is implementing it, is supporting it, we have to continue on this and do our different ways to make this successful. And having a look to the methodology of the steel recycling, not going into the depths of the two different routes of steel making, the basic oxygen furnace and the electric arc induction furnace, you see it is scrap into the electric arc furnace and into the induction furnace. And the 6 R's, the reduce, reuse, recycle, recover, redesign, and remanufacturing, does require various things: logistics, processes, but also quality control and quality assurance. Because being successful, being competitive, feeding the furnaces with scrap, we need to understand, we need to know that which type of quality, which type of scrap is going into the furnace, so that we have a minimization of errors or failures. Having a draft look to the two routes, you see here on the electric arc furnace / induction furnace on the right side that the majority is used scrap, and you can see the reduction of CO2 and the cost reduction per ton in emission and in production that the electric arc furnaces, induction furnaces will have to be increased into the steel manufacturing. Not to say there are still, due to certain purposes and certain developments in the history, the basic oxygen furnaces will still maintain their availability, but the push and the focus is on induction furnace, electric arc furnaces. Now, the key point, looking to the National Steel Policy 2017, India may become a key destination, a hub, I will say, for unprocessed steel. But what does that mean? The estimation is that 700 scrap processing centers are required, and they are all fed by 2,800 to 3,000 collection and dismantling centers. That requires logistics, that requires quality management, and that requires analytical instrumentation to ensure, to understand which type of quality this unprocessed scrap does have before it gets processed. I think this overview you all know, looking to the NSP 2017. where we have the scrap processing center, the dismantling center, the individual and various routes. I do not want to go into the details here, but a key point is logistic may become the main challenge for all this to set it up, like roads, like cars, like infrastructure, in order to make it operative and homogeneously working. So this so far is so good if we have the infrastructure. But another important challenge is that we have to ensure that the material, the scrap ordered and processed, does have the right quality and material composition. Why? Because money and time matters. I'm coming to various parts of this at a later stage. You can see that the loop then is closing. We have to look to the London Metal Exchange market and have a look to the steel scrap graph. Here you see steel scrap, and those people who are trading with the steel knows that it is fluctuating up and down. Having an example here for the 3 or 4 steel grades, you see we have nickel to a certain range of 8 to 12%, and we have other alloying elements here. So not only looking to the steel graph, we also have to have a look to the nickel value, how it is fluctuating, because out of this, we may get some interesting part and interesting calculation. And at this stage, I would like to mention that large steel plants, and you may already know it, they do have already comprehensive apps for sourcing of steel. So they are available to source steel and scrap and to do the trading, because as of today, we have a 24/7 trade globally, independent where you are, independent of any time differences, and therefore it is important to be adjusted, adapted to the digitalized world. Now, the fact is, we need to do right investments to ensure quality. And here is a quick example. If a scrap dealer has 100 tons of steel, which contains 8 to 12 nickels, and coming back to the earlier slide where the nickel value is, in order to make money to trade with this, he has to go for analytical instrumentation and to do the metal analysis on site, because he may sort out that 70 tons has 8 to 10% nickel and 30% has 10 to 12% nickel. So the value of that nickel scrap is different from the original, where you have only a mixture of 8 to 12. So you easily can calculate, depending on the trades, how much money you will gain and how much you can gain. And if we look to the left side, the 304 and the 304L grade, where you have this in common, where 8 to 12% nickel is in the same grades, but nobody can distinguish by looking, is it an L grade or is it a non-L grade? You need to have an appropriate spectrometer, like a mobile one, which is able to exactly accurately determine the carbon content. And then having this distinguish L grade, then you can even more trade in a different way, and then you can bring back the money, which the additional cost saving can go either into the infrastructure of the company, or it can be invested to purchase additional spectrometer to even improve additional requirements for applications. Here, I show you a typical analysis when we are talking about the steels. You see, just focus on carbon. The L grade, you find 246, 243, 247 ppm of carbon. This definitely defines you have an L grade. In addition to this, you get all additional compositions of alloyed element and also trace element, and you get a grade identification. To this part, I'm coming a little bit later. Having this explained, the theoretical part, and where you see, this is where smart recyclers and scrapyards require analytical instrumentation using the latest technology, because the latest technology allows high quality. So we are offering in our spectrometers and the toolbox kind, handheld XRF instruments, the XMET 8000 series, the LIPS laser-induced breakdown spectroscopy, Vulcan series, and mobile and stationary spectrometer, optical emission spectrometer, where depending on the need, depending on the requirement, each individual instrument does have the purpose to serve the demands. So here I'm not going into the details here, how this operates. We are offering additional webinars for the individual products, and we also offer live demos on site to see how it works. So if you have to go for small samples, if you have to go for non-destructive, a lot of elements to be analyzed, we can offer the XMET 8000. The Vulcan series is a CCD-based spectrometer where you get analysis in 1 second, where it is very lightweight, easy to carry, battery powered, and simple to use for each and every operator. The mobile and stationary spectrometers is adding up where customers are looking for precise percentage analysis, where they are looking to CCD or CMOS-based technology, allowing ppm level trace element determination, where nitrogen might be a request, and where we have to analyze also the boron, the sulfur, the phosphorus. So all these instruments are part of our toolbox where we can offer to the tailor-made application for the individual requirements. And which are the requirements? Which kind of work is required? Some scrap yards, some scrap dealers are doing the sortings. Some of them have to do accurate chemistry analysis. So I'm not going into the individual areas. The major part for you being in the scrapyard, not necessarily only dealing with the steel scrap, occasionally also having non-ferrous, all of our technology, which I'm explaining here, can cover the ferrous as well as non-ferrous application. As an example, if somebody is only needing to do sorting, and it has to be done in the scrapyard itself, where no accurate analysis and chemistry is required, where no trace elements are required, just go for no-go decision-taking, analysis time 1 second, we can suggest the Vulcan series. Where chemistry is required in the scrapyard itself, where we have to go for accurate chemistry, but actually no carbon sulfur, but trace element might be required, we offer the XMET 8000 series and the PMI Master Smart. Which one actually to be used? That needs to be discussed and depends on the requirement of the customer. And I can tell you, strong and large enterprises of scrap recycling, they are using 5 to 10, even 12 handheld analyzers, XMET 8000, plus 3, 4, or 5 PMI Master Smart. So we are not looking to only one instrument each, we are looking to multiple instruments because that helps to reduce the working time, let's say from 3 or 5 days down to 1 day to get the job done. If chemistry is required in the scrapyard, but where the requirements are on accurate trace analysis, accurate carbon analysis, high flexibility in application, element selection, and application, where L grades are of interest, our suggestion here is a PMI Master Smart spectrometer using the latest technology of CCD. Now the next part is coming into this, a lot of large enterprises, also medium enterprises, besides the on-site application, they do also have a scrapyard laboratory where they get the scrap remelted and put it into blocks depending on the cast form for selling. Here the demands are completely different. We are looking into ppm level. Besides alloyed element, we have to do furnace control, and when selling this scrap as a block coming from a furnace, a certificate of analysis is required. And for this part, the people have to go for the stationary spectrometer OE750, which is latest CMOS based. So depending here, and this is only an abstract of what it is possible, we can offer a large variety of a toolbox. So far for this application, this is the hardware, I will say, which can do the job. But within this smart recycling, having the smart analyzers, we need to work with smart software because we are going into the digitalized world. At this stage, we are offering 4 different software tools. For each software tool, which I mention here, we do have separate webinars because I can only scratch on the surface here. The webinars each will have half an hour to 45 minutes explaining in the depths the comprehensive software tools, how it supports to get the analysis done and complete to the requirement. So I'm coming first to the great database, and talking to the great database, I'm going back to this slide. Here you see it is a grade 1.4306, which is a 304, but that is a German norm. And you may say, yeah, but this is a German norm. We are trading in ASTMs, so 304 grade. Yes, we know, but please, we don't need to forget, we are a globalized world, and looking to actually the roots of scrap, it can come from each and every part of the world. And therefore, our great database, which we offer, covers 320,000 different metal grades from 69 international standards. And if you look to the steel grades only, where we have an approximate 3,500 metal grades, the software is a help. It saves time because the online search makes manual search in literatures obsolete and reduces the possible errors to a minimum. And this is an example which integrated in the great database, which is the GIS, German norm, ASTM, and of course the British standard. Various other Chinese standards are integrated, and therefore we need, or everybody who is working and using the spectrometers must have the access to a great database. Xtopy Connect, for example. This is a part which is going into a cloud-based software where we have real-time access to the result from any computer, anywhere where internet connection is available. Because here we can manage large amount of data, large amount of analysis in real time. How does it work? You get your analysis with the analyzer. You have to download the app, Xtopy Connect app. Then you have to have a mobile data access or a Wi-Fi access, and then it is uploaded into a cloud. Okay, what it is doing in that cloud, how does it help? Here is an example. There is a recycling plant in India, and the owner, the boss man, is traveling, let's say to the US or any part of the world. So he is not personally available around here. And how can he judge on the results taken? So using this Xtopy, when the measurement at the recycling plant is continuously going on, the data are uploaded to the cloud. The boss man has access to the results, as you can see on the right slide, and he can take an immediately decision to say, okay, sell the scrap, or no, we need to wait a little bit. So that means there is no time loss, depending on the fluctuation, as we have seen from the values in the London Metal Exchange market, and also the trading market within India. Quick decision in real time can be made, and that helps to save costs and make decision and to play on the logistic of a scrapyard. Charge correction software. This is a part when we are talking about furnaces, not only induction furnace, but also basic oxygen furnace. As of many areas, charge correction when feeding the furnace is mainly done without software. But today, high risk is there that it is implemented wrong calculation, wrong addings of items, materials, and this will then result, if you do so, and you recognize it too late, that melt you are feeding is already obsolete scrap. So it's homemade scrap. So therefore, we are offering the charge correction software. And here you see a little bit the cost saving when we are calculating based on one induction furnace with one ton capacity, 6 casts per shift. So we can calculate about $26,400 savings per year if we are using this charge correction software. Of course, here we need to look a little bit tailor-made if somebody has a 500 kilogram furnace or a larger furnace, and which is shifts he is looking at, how many casts. So this software helps to be flexible to the needs and to the requirements. So the benefit definitely is avoiding home scrap using this automatic charge correction software. And the next part is here, the SPC software, statistical program software. This helps definitely large enterprises, but also small enterprises to optimize their processes, to get information about various charge, how the elements in the melt behave, how the production or the melt behaves over a certain period of time. And that also helps to be process conform, reducing costs because I have a much better observation about my processes, reducing the failure rate. So therefore we can increase the efficiency, and we have a maximized productivities with minimized failure rates and increasing product quality. So all these items like limbs and what we have are standard supply with our instruments. So coming back to this part, and since I do still have some 2-3 minutes, I would like to just come and ask thinking beyond the ferrous scrap. And why I'm putting this up, thinking titanium. Thinking titanium is where we are going into the aircraft industry, to the space industry, and into the medicine and various areas. And we see, being in that market, that the titanium industry is eagerly looking also for high productivity, high demand, and that titanium has been understood as a valuable scrap. So valuable scrap means more money can be obtained compared to the ferrous scraps, and the one or other scrap dealer may open up his additional leg looking into the titanium industry, where specifically hydrogen, nitrogen, oxygen, and carbon is required. Here you can see a little bit an overview, not going too much into the details of this titanium manufacturing, but the hydrogen, nitrogen, carbon, oxygen, according to their physics and chemistry, are fundamental elements which will be analyzed. As of today, in many of these plants, this is analyzed, these elements, by combustion method. But combustion methods is very expensive. And I have a small overview here to see how cost saving can be done using optical emission spectroscopy in combination with combustion when elements needed to be analyzed. So looking to that, looking to each individual element analysis of carbon, hydrogen, nitrogen, as well as oxygen, you can save a tremendous amount of money, talking about 20,000 samples per year. The key point is here, titanium alloys, as it goes into the medicine, where we have to get various joints and items manufactured, and goes into the space and aircraft industry. This is a market where precise results are required. I give you a quick example, an overview about the results. You can see here nitrogen, oxygen, hydrogen. We are talking about ppms. For nitrogen, in an average 87 ppm, hydrogen about 15 ppm. So this makes it worth to look for optical emission spectrometers in the foundries, in the smelting plants. And the one word I would like to say is that the combustion analysis is still required, but optical emission will take over a large part, reducing costs and ensuring quality, which is additional interesting market segment where scrap dealers who are looking in the steel industry, also having non-ferrous scraps, may look for the titanium market, because being that valuable market, they can obtain a lot of money, improving also their infrastructure. So having this explained in all details here now, I would like to thank you very much for participating and listening. I wish all of us to be staying safe and not to forget that people makes a difference for the new world where we are all living in. Thank you very much.
Thank you, Mr. Frank, for such a detailed presentation. I hope our participants will really get great benefit out of this presentation, and will try and approach Hitachi High-Tech team for the solutions which you people are providing. We have certain questions for you, but due to time constraint, I'll first go ahead with the next speaker, and in the last we will take the questions. So thank you so much. I would like to now welcome Mr. Adrian Smith, Global Sales and Service Director, Hitachi High-Tech Analytical Sciences. Mr. Smith is based out of Singapore, and having worked in Asia Pacific region for more than last 23 years, he has a clear understanding of the Indian business and trade links between China, Southeast Asia, and with India. With an engineering background and over 25 years of experience in metrology and analytical instruments, he has been managing and leading both the commercial and technical teams globally. Mr. Smith, the stage is yours. Go ahead.
Thank you very much. So just before I share my screen and the presentation, I would like to just say a big thank you to MRAI for making the arrangements and giving me and my fellow participants, panelists, the opportunity to talk about the role of advanced technologies related to the India recycling business. I would also like to say thank you to the participants for your valuable time and joining the seminar today. I will share my screen now. I'm going to just switch the camera off to save bandwidth as well, and I'll share my screen now. Okay, so I hope everyone can see the presentation.
Yes, we can see the presentation and we can hear you. Mr.
Okay,
Smith,
very good.
ahead,
okay, so what I'll be presenting now is I will introduce Hitachi, the company, and then I will zoom in to the business unit of Hitachi High-Tech Analytical Science. We have just heard from Frank a lot of very nice detail around how our products fit into the recycling business, and I would like to go into a little bit more detail about how our company strategy and values are well aligned with MRAI and I think the Indian recycling business and the future. So just to begin, I'll say a few words about Hitachi's major business segments. I would describe it as that most people know Hitachi, the brand, but less people really know the broad offering of technologies that we have across these major business segments. And I think it's good to start with the Hitachi corporate mission, which is to contribute to society through the development of superior original technologies and products. So what you can see in this slide, these are the major segments broken down by percentages where Hitachi is present. And as you can see from this, we are very heavily involved in industrial and infrastructure related industries. So for Hitachi, the business is broken down into 5 main business segment solutions. This includes mobility, smart life, industry, energy, and IT. By combining technologies, Hitachi is enhancing customers' social, environmental, and economic values while contributing to people's quality of life and improving that quality of life. I think when we look at the objectives and goals of MRAI, we see that the Hitachi values are aligned quite nicely with these goals. At the bottom of the slide, you can see the term Lumada. Lumada is Hitachi's advanced digital solution. It includes services and technologies that are created to bring value from our customers' data and digital innovation. Frank did go through some of this in his presentation, which in our business, we have what we call Xtopy, which is basically enabling the data to be sent into the cloud so that it can be managed by the customer. So how do we fit into Hitachi? We are part of a group company called Hitachi High-Tech. This is comprised of, you can see, 3 business segments. The first one being analytical and medical solutions business. The second one being the industrial solutions, and the third one being nanotechnology. We are located in the analytical and medical solutions business, primarily for 2 reasons. The first one being that we do incorporate higher technologies in our instruments, and we can leverage the R&D knowledge and experience from other businesses within this group. The other reason is more of a commercial one, that we have collaboration and cross-selling between our business as well as several other businesses within Hitachi High-Tech. What are we bringing to our customers, and what do our products offer? I think fundamentally what we are bringing is measurement and analysis systems that fully characterize materials and goods. And this allows for our customers to make quick and fast decisions. We typically are taking proven technologies that are used in, as an example, used in a laboratory, and we take those technologies and repackage them into a fit-for-purpose instrument that is easy to use and is rugged enough to survive in difficult environments. An area that we do specialize in is in miniaturization of the technologies and the development of the software to basically make the instrument easy to use. We do also see an increasing demand from our customers related to data management, which we are incorporating in our latest software. I'll speak a few words about our vision, mission, and objective. Our vision is to support our customers' high technology processes, and our mission is to help our customers to be fast moving, successful, and cutting edge. I think that while these are basically simple statements, that they're very relevant for the recycling business and where it is today. This is an exciting time. We do see the possibility of high growth and an expansion of the use of technology, and I would say more efficient processes, and also collaboration between different businesses to really find solutions to big problems. The next 3 slides I have are related to the industries and applications that we sell into. This is at a very high level, but can give you an idea of where our particular business and products are being used. So manufacturing quality control, so verifying the alloy that is being used, in-field inspection in petrochemical applications, metal production, and electronics production, which gets into more of a coating thickness type application, which we do have products that support. We have general metal finishing, which is also typically a coating thickness application in industries like aerospace and automotive. Of course, we have scrap metals, recycling, petrochemicals, and fuels, and then we have mining, minerals, and cement. And the last area that our products are present is partially driven by regulation. So we get into regulatory screening, which is really following a regulation around ROS, and this also has an implication in the ELV, or end of life of vehicles. We have instruments that go into wood preservatives, which is a fairly big market in certain countries like the US. Release liner is looking at silicon on paper. And then the last one, which I think is very important for what we've discussed, is related to environmental, and this is primarily looking at heavy metals in soils. And we have the handheld XRF instruments which go into that, and then we also have our benchtop instruments. So for global locations, we are a multinational business. Of course, Hitachi has locations all around the world, but for our particular business unit, we have offices located strategically. I will focus on South Asia because I think it's the most relevant for this discussion. But basically in India, we have our main offices in Mumbai, and that office is supporting sales, service, applications. We have another office in Delhi, which is a shared office between several businesses. And we also have engineers located strategically around India. On top of that, our key partner and distributor in India is TII, and they have 10 offices in India, with 3 of them having service capability. And they also have an office in Dubai. And then for Southeast Asia, we have our Singapore office, which is where I am located, and I am in the office right now. And the Singapore office has full service capability, and then we have distribution around Southeast Asia. So I think from a service and support standpoint, we're well covered. And then on top of that, we have offices in Japan, China, Europe, and US. And this, you know, I think another main point that was touched on in the in several of the other slides is that scrap metal recycling is very much a global business, and companies are conducting business with each other internationally frequently. So I think we're well positioned to support our customers when it's needed. And that concludes my presentation. Thank you very much.
Thank you, Mr. Adrian. May I request all the speakers to please switch off your cameras. Switch on your cameras. I'm so sorry. So with this, we will be starting our question and answer round. I once again like to thank our sponsors, Hitachi High-Tech Analytical Sciences, for sponsoring this webinar. To go ahead with, my first question is to Commodore Sujit Samadar. Sir, I have received 2-3 questions, but I'll try and mix these questions in one question. Is like, what will be the estimated cost of the project, and what will be the minimum space requirement for this project? Can you throw some light on this?
Thank you very much once again, and my congratulations first to Adrian and Frank for the wonderful presentations. Very, very interesting, and I think there's a lot of learning into it. I have some questions to Adrian and Frank subsequently, but let me first turn to Amar for his query. The estimated costs depend on the capacity of the plants that we have, and that can range from as little as, maybe $600,000 to $1.5 million, which is not a large amount of money, and $1.5 million is good enough for a 100 TPD, for a 1000 TPD plant for steel very easily. The space requirements, these are all extremely compact systems. So I think the largest plant, or to cater for 1000 tons per day, we can do bigger than that, would still be in the range of about 30 meters by 4 meters, 120 square meters. The whole commissioning from placement of order to delivery is about 6 to 8 months, depending on the model that is followed. But where I would really like to see is that don't import it, make this in India, and we're looking for partners to build this in India with all the support that we can provide from Canada to do this as part of the Prime Minister's call for Atmanirbhar Bharat, and we are quite willing to export it from India to places where Hitachi is present. So maybe even Hitachi can join us in this effort of bringing green technologies across the world. Thank you.
Thank you very much, Mr. Samadar. My next question is to Mr. Frank. Mr. Frank, can you just give an overview on the advantages of portable OES over PMI gun?
Yeah. If I understand the question about the portable PMI gun, I think we are talking about the handheld XRF
Yes.
instrumentation. And when we talk about the OAS mobile, we are talking about the PMI Master Smart.
Yeah.
Okay, obvious is that the handheld XRF is definitely more light and can be easily carried around. So that is, from the visible point of view, the first difference. Now, looking to the differences and individual advantages, that depends on what you like to do. The major advantage of having an handheld XRF is because it is non-destructive. It can be used for non-destructive testing and very light, easy handling and easy carrying. However, if you look and specifically look to the mixed material which we find in the scrap yards, then we need to see, do we also have to analyze trace elements or specifically carbon when we talk about carbon steels? So then you definitely need to use optical emission spectroscopy, which is the mobile spectrometer, over the XRF fluorescence spectroscopy, analytical spectrometer. And then you need to understand which way for the purpose you can use the most suitable instrument. So actually speaking here, that to me, both of the technologies, the mobile OES as well as the handheld XRF, are a mandatory instrumentation which needs to be used both in the scrap industry. And I hope I could answer as best as possible, not going into the more details.
So going on your answer, I have another question.
Yes, please.
In India, there in next 2 to 3 years, there are high chances that more and more scrap yards will be coming. So what do you suggest? Which technique is better, portable OES or handheld XRFs? In the initial stage, scrapyard owners should go with which technique? Can you throw some light on this?
Yes. Unfortunately, there is in our world not the one and only technique. So we have to live with various technologies because we have to look what are the requirements, the demand, and which quality expectation requirements we have. However, looking to your question, to the scrapyards, to the developing, there is a majority of demands going towards handheld XRF, but also, as for the examples what I have mentioned, mobile OES needs to be supplied in the scrapyards as well. So we can see a tendency, and that depends on small, large or medium-sized scrap dealers or scrapyards dismantling parts, that you can see in a large scrapyard, about 10, 15 handheld XRF are with one scrapyard only, plus 2 or 3 mobile OES in one scrapyard only. So we can talk about 10, 12, 15 spectrometers in one scrapyard, where the majority at the moment, due to the purpose, is for handheld XRF, and for the special task, like carbon, like nitrogen in duplex and so on, and trace elements, and the flexibility between low alloy, stainless steel, tool steels, and so on, and non-ferrous, mobile OES needs also to be there. So the answer is there is not one and only solution. Handheld XRF, mobile OES are complementary for the requirement and needs. Cannot hear you.
Thank you so much, Frank. And my last question to you is, what is the best technique for sorting aluminium scrap, like mixed Zorba or Zurich?
Yeah.
Can you throw some light on this?
Yes. And looking to the question while talking about sorting, the best technology which I can offer here is the LIPS technology, which is introduced by our spectrometer called Vulcan, where we have different series models of Vulcan depending on the requirement and needs. And the key point is here, while doing sorting, the requirement is sorting, go, no go, but very fast. So Vulcan offers you 1 second of analysis. You get the information I can use, I cannot use, I do the sorting. So for this purpose, I would suggest to go for Vulcan. And depending on the requirement, then we need to talk which appropriate model within our Vulkan series will be the one appropriate for the customer needs.
After listening to your answer, I have one more question to you, is that how many samples can we analyze with Vulkan and with portable OES?
Naja, this is a question, an amount of samples. It is difficult. It's not difficult to answer. The quick answer would be as long as the battery lasts, and the battery lasts 8 to 10 hours for the Vulkan. And if you calculate 1 second per sample, then you can calculate quickly how long you can work with the instrument. However, it is always and also considered, and I don't want to go into the depths, but I'm prepared for those who have raised the question to discuss in details. It is not only the question of how many samples in general, we also need to see which type of quality. If I have, for example, aluminium silicon or aluminium copper silicon or aluminium magnesium or stainless steel, tool steel, or even cast iron, then the analysis time depends because of the requirement. But I can tell you, couple of hundred, if not 1,000 samples can be analyzed with one charge of battery.
That's great. That's great. So this will surely help our scrapyard owners to get the best out of the scrap which is lying in their scrapyard. So my next question for Adrian is, Adrian, can you tell us what are the trends of technologies being used in other markets like Southeast Asia, US, or China?
Yeah, good question. I think the way I will start to answer the question is to talk a little bit about the history. So handheld XRF roughly came into the market about 20 years ago. And initially, the initial instruments were large and bulky and did not measure very many elements. And as they were introduced into the market, a few customers adopted the new technology. And I think even when we looked at, even if you look back at 10 years ago, not all of the scrap recyclers were using handheld XRF. And over the last 10 years, what we've seen in Southeast Asia, China especially, is more and more adoption, even by the small traders. So today, we can say the tier 1 and tier 2 scrap recyclers will typically have a handheld XRF. I think in the last 5 years, what has been changing is that scrap companies are starting to adopt other technologies. And the technologies available today, of course, are libs and optical emission. And Frank, during his presentation, he talked about something that's very important, which is the toolbox. And the toolbox is the optical emission, both portable and stationary, handheld libs, and the traditional handheld XRF. And I think the change that's taking place is that companies are recognizing that they do need the multiple technologies to be able to get the right results. And so whether they're doing a duplex steel or they need to measure the carbon, absolutely they need to use an optical emission. And then Frank had one slide which also included a stationary OES, which can get better results on lower values of carbon. And we are seeing more and more scrap recyclers purchasing that type of instrument. And then, of course, when you get into titanium recycling, which is very big in the US, we actually will sell the handheld XRF, the stationary OES, the higher end systems, and we also have a mobile system which performs very nicely for that. So so I think the toolbox is really the key. And I do think when we start to look forward, I do think that data management will become very critical. And at the moment, I would say when I look towards our customers, the bigger companies are taking data management very seriously. And the data can be used in different ways, but it fundamentally can be used to make their operation more efficient. And so when you look towards the larger trading businesses, they are especially now with the situation, they are absolutely looking at efficiency. So I think when you look forward to the next 10 years, we're already seeing the introduction of the toolbox, and I think the next step will be data management. And we're, as we presented, we are getting ready for that change in the industry.
I agree with Adrian that in India also I have been visiting small yards, scrap yards, wherein they are just sorting or segregating or doing business of 1 or 2 containers, but they are also having this handheld machines, which gives us a good satisfaction to us that wow, our industry, which is very new, like recycling in India, informal sector is very new, but then too, they are using the advanced technologies to get better cost effectiveness out of it. My last question is to Mr. Samadar. Mr. Samadar, can you please put some light on how will hydrogen electrolysis help in reducing cost and emissions? Mr. Samadar, yeah, you are muted. Can you please unmute yourself?
Yeah, I'm unmuted. Can you hear me now? Yeah. Okay, that's a wonderful question. And maybe with Hitachi, we should have another detailed webinar on the applications of hydrogen as a fuel. As most of us who have been following the technology on fuel, hydrogen is definitely the future fuel. And the method of generation of hydrogen was quite complex till a couple of years ago. Now advances in chemistry, where I think Frank is the guru as far as chemistry is concerned. I should not open my mouth too much about chemistry. So, but I'll just leave it to him to say that generation of hydrogen through the electrolysis product generates hydrogen as the primary product and oxygen as a secondary product, as I showed on the slide. Now, the point is the electrolytic medium is water, and the quality of the water matters. So here again, technologies have now developed by which you can use renewable energy sources to run reverse osmosis plants, and those reverse osmosis plants are the feed into the electrolytic system of the hydrogen electrolyzer. So there is zero emission in the generation of hydrogen and oxygen. Both the product and the co-product are useful for industry in various ways. So that is the first aspect of hydrogen. Now, if you add other sources of it by which you can generate hydrogen through biomass degradation or various other technologies, then you can also generate nitrogen, as I said, and you can also generate carbon dioxide, as I said. So all these gases have several applications, and it's quite possible to design systems which use all the technologies that are available, harness them, put them all together to get these fuel efficient, emission efficient, and cost efficient solutions for the recycling industry.
Thank you so
much. I have
much.
some questions if you let me
please, because go ahead.
Okay, so thank you once again for some very interesting questions. Frank, this one is to you first. You know, I can't leave behind my Navy uniform even when I'm with the Material Recycling Association. So I always think of security issues. I think one of the issues that always face us in today's world is this whole business of terrorism and drugs and mafia and that sort of thing. So your spectrum analyzers have, basically it's about hydrogen, nitrogen, oxygen, and carbon. The way these four major elements are put together, they either create food, or they create drugs, or they create explosives at a very simplistic level. So looking at a sample and seeing whether it's got more nitrogen and hydrogen on it gives an indication to somebody that this might be explosives. Or if it's got oxygen and hydrogen, then you can think that probably it's got drugs in it. So that's one idea that I want to leave with you and maybe hear your views on it. That's the first part. The second part here is the little tricky part, but I want to go into it straight away. Whilst this device is very useful for the scrap recycling organization, I think this device has also a large amount of market for the pollution control agencies. I don't know if that works or not, because we have a large informal sector, and they produce a lot of pollution in terms of automotive sector particularly, or the e-waste sector through leaching mechanisms. There's a whole lot of it. But by the time the evidence is collected, by the time the judiciary and the criminal guys get together, he says this doesn't belong to me. So now, if your handheld spectroscope, handheld meters can analyzers can actually pinpoint that, look, this is the material, and there's so much of cadmium, there's so much of mercury, there's so much of cobalt in front of your office, and you are culpable for it. That might bring in a lot more discipline into the informal sector. So that's my second question. Third is on the production side. Whilst on the recycling sector, we are looking at the quality of the scrap that we are getting. But as a production person, I would also want to be assured that if I ordered a particular alloy, then that is actually the right alloy that has come to me without doing some extensive testing. So there can be potential applications of this technology also on the production floor of metal industries. That's the third question. And after having given you all these business ideas, I want to ask you one question. What will it take to set up this plant in India? Why don't you set up this plant in India? Since the business volumes look good, we'll open up several more opportunities for marketing of products to a larger market than the scrap thing. So please give it some thought. Frank, your comments, please. Thank you.
Yeah, thank you very much for these suggestions on the parts on discussions, and I'm quite sure there are some value in these questions, which I suggest that we definitely need to discuss them offline, as we have to go into more details and into more discussion points. But talking about the analysis of our technologies from the toolbox, we are able and capable to analyze with our instruments, mobile lid spectrometers, various type of metals, which can be analyzed and also, for example, in plastics and so on. And the other part is when we are talking about pollution and dust collection, then we have to also use different technologies, which is going to atomic absorption or ICP, because the requirements are here completely different to the instruments in optical emission, which we can fulfill. So that is what we need to see. We have to look to complementary application, complementary instrumentation. And as I said, let us discuss this offline, because then there are a little bit more discussions to be met and points to be raised, which might be not of interest for the audience right now. But coming back to the scrap industry and scrap market, the toolbox which we offer, what Adrian has mentioned, from handheld XRF, lids, mobile and stationary optical emission, that covers 100% of the need and requirements of a scrapyard, either small, medium or large scrapyard. And it does not only look to the ferrous scrap, metals, material, but it also looks to the non-ferrous. So we do offer for the future, for the next 3-4 years, any scrap dealer who might open up a second or third leg, for example, titanium, he can come back to us. We can show with an instrument demonstration how it fulfills to his requirement.
Thank you so much. Thank you so much, Mr. Frank. Thank you so much, Mr. Adrian. Thank you so much, Mr. Samadar. I have been receiving so much questions from my speakers, from my panelists. which they are asking me to ask you, but due to paucity of time or lack of time, I can say, I will be sharing all your details with my panelists, with my attendees, so that they can directly get in touch with you all and ask the questions offline. With this, I would like to once again thank every one of you and request my colleague, Mr. Pramod Shinde, to give a vote of thanks and end this webinar. Yeah, Pramod, go ahead.
Thank you very much for such a wonderful presentation as well as the key insights of the industry. It's a great privilege to represent MRAI, to present the vote of thanks for the contribution and efforts have made for the success of today's webinar. We are very thankful to distinguished speakers and delegates and our sponsors, Hitachi High-Tech, who have participated at today's webinar. I place on record a deep sense of gratitude towards our distinguished speakers, Mr. Amar Singh, Secretary General, MRAI, and entire MRAI Board of Directors, Mr. Commodore Sujit Samadar, ex-Senior Consultant, Niti Aayog, our distinguished speakers, Mr. Adrian Smith, Global Sales and Service Director, Hitachi High-Tech Analytical Science, and our distinguished speaker, Mr. Frank, General Manager for Global Distribution OES, Hitachi High-Tech Analytical Science. With this, we express grateful thanks for the sponsoring today's webinar by Hitachi High-Tech, whose wholehearted support has made this webinar with more resourceful. I thank all the distinguished delegates once again who have accepted our invitation and given their precious time. Thank you for joining us today's webinar. Last but not the least, that we must appreciate MRAI team as well as Hitachi team, Neha, Mahendra and Sandeep sir, and from MRAI's entire MRAI team for their untiring efforts to organize today's webinar. Thank you, ladies and gentlemen, for joining us today on this occasion. Thank you very much. Thanks a lot. With this, wind up this today's webinar. Thank you once again. Thanks a lot.
Thank you.
Thank you very much, and have a nice weekend.
Thank you. Thank you.
Have a good day. Thank you.
Bye-bye.